For the last decade or so, there's been one number that's basically ruled all the headlines. It's on protest signs, it's in government treaties, maybe even in your nightmares a little bit. 1.5 degrees Celsius, the line in the sand. We've been told over and over, stay under it, and, things are manageable. Cross it and, well, just don't cross it. But here we are. It's mid-2026, and looking at the paper I'm going to tell you about today, the mood, it feels like it's shifted. It's not how do we avoid crossing the line anymore. It's more like what happens now that we're probably going to miss it. Because the data is becoming, well, undeniable. We're on a trajectory to miss that 1.5 target. But the nuance, and this is what we're diving into today, is that missing it doesn't mean immediate apocalypse. It means we're entering this very specific, very messy phase called overshoot. I know that sounds almost technical, like a budget thing where you spend too much, but reading this new paper, it sounds a lot more like a warning siren. And indeed it is, but for a very specific group. The paper's titled The Human and Social Impacts of Climate Overshoot. And the authors represent a collaboration between several institutions and researchers from around the world. Top-tier climate scientists working with the people who are actually on the ground. And their message is unsettling. They're basically saying that while we have really good computer models for what the weather does when we cross 1.5 degrees, like the storms and the heat waves, we have almost zero systematic knowledge about what society does. That's the blind spot they talk about. So we know a great deal about the physics of a hotter world. We just don't know the social implications. We don't know how supply chains or migration or healthcare systems really behave under those conditions. So when they say climate overshoot, what exactly are we talking about? Climate overshoot refers to a temporary period where the global mean temperature, the GMT, goes above 1.5. The plan, or the hope, is that we can bring it back down later in the century. Now, temporary is doing a lot of work in that sentence. And that's the scary part. Under the current pledges countries have made, we aren't just barely crossing the line. We're on track to significantly exceed 1.5 degrees before the 2050s. The paper suggests we could be looking at a peak of up to 2.6 degrees Celsius if things go really wrong. And we'd be stuck there for decades. That's the core of this episode. We're entering a gap, a period of 30, maybe 40 years, where we're all living above the safety limit. And the question this paper asks is, can our current civilization, our food systems, our disaster relief, can it actually survive that gap? It's like the difference between knowing a hurricane is coming versus knowing if the hospital will still be standing afterwards. And the timing here is important. We just passed the 80th anniversary of the UN. There's this massive debate happening right now called the humanitarian reset. The whole aid sector is realizing its old methods, they just don't work for where we're going. They're worried that they're walking into a disaster because they're underestimating how messy this is going to get. Okay, so let's get into it. The authors of the paper lay out 5 specific factors that policymakers and planners ought to consider. And I want to go through these because each one sort of dismantles an assumption that I had. Factor 1, peak warming and duration. How hot and for how long? It seems simple enough, but they make this point about buffering that I hadn't really thought about. There's this idea in policy circles that the climate is like a rubber band. You stretch it, you heat it up, and then when you cool it down, it just snaps right back to its original shape. But nature doesn't really work that way. Some parts do. If you have a massive spike in air pollution and you turn off the source, the air clears pretty fast. The atmosphere buffers that shock and recovers. But other systems, they break. They don't snap back. Think about an aquifer. If you have a 30-year overshoot that causes a 20-year drought, you pump that aquifer dry just to survive. Even if the temperature goes back to normal in 2060, that water is gone. It takes centuries to refill. That's an irreversible loss that happens during the overshoot. And this connects to the money side of things too. You can survive one bad year, you borrow, you use savings, but you can't run a deficit for 40 years. Humanitarian groups work on the idea of an acute crisis. A disaster hits, we raise money, we fix it, we move on. But in a long-duration overshoot, the disaster just doesn't stop. It becomes the new baseline. You drain all the reserves. And that leads us right into factor number 2. Geographical amplification. We talk about 1.5 degrees like it's the same temperature for everyone. But 1.5 is a global average, That includes the oceans, the poles, but nobody lives in the global average. So where does the heat actually go? Because if it's 1.5 globally, some places are getting hit way, way harder. And the article flags these hotspots. The Arctic is obviously warming faster, but also West and Southern Africa. These regions are warming much faster than average. So while a resident of a temperate city might feel a manageable 1.5 degree rise, a farmer in the Sahel could be facing a 3-degree reality or more. And the paper uses this term hydrological amplification. It's basically the water cycle on steroids. More heat means more evaporation. So in these hotspots, you get worse droughts and worse floods. But the real injustice, and the authors are so clear on this, is that the regions with the most extreme physical amplification are almost always the ones with the highest social vulnerability. The places with the least money to build defenses are the ones getting hit the hardest. Take the Arctic, for example. It's not just that the ice is melting. The entire world in which those communities live in the Arctic dissolves. Transportation over ice is gone. Hunting patterns their ancestors used are gone. The land itself changes from solid to liquid. You can't just adapt to that. So location matters. But then there's factor 3, the timing of arrival. We always focus on the absolute number. Is 2 degrees okay? But the paper argues that the rate of warming, how fast we get there, matters just as much. Systems, both natural and human, have a speed limit for adaptation. There's an example of coastal cities. Think about retrofitting a city like Miami or Mumbai for bigger storm surges. It's a massive engineering project. It takes planning, funding, years of construction. Maybe it takes 20 years to build a proper seawall. But if the overshoot happens fast, and that monster storm is in year 5, and your wall isn't done until year 20, that investment is almost worthless. You were just too slow. And it's not just the known hazards, it's the surprise ones. A region that's dealt with river floods for a century knows the drill. They have levees, they have evacuation plans. But if overshoot suddenly brings flash floods, which are a totally different beast, hitting in minutes instead of days, the local government has no playbook. They're prepared for the wrong war. And they don't have time to learn the new rules. Which brings us to number 4. Adaptation limits. Hitting the wall. They talk about something in here that I found quite disturbing. Maladaptation. This is a huge risk, especially in the sort of panic phase of overshoot. Governments will be desperate to do something, anything. So they rush into these short-term fixes that actually make things worse down the line. What does that look like in the real world? Air conditioning is a classic example. It gets hotter, so everyone installs AC that uses a ton of electricity, which, if your grid isn't green, just pumps more CO2 into the air, making it hotter still. It's a vicious cycle. Or building a giant dam to stop floods, but in doing so, you destroy the local ecosystem that people relied on for food. The paper really digs into this idea of sinks becoming sources. This feels like a massive gamble we're taking. Our global plan relies on nature helping us out. We assume forests and oceans will just keep soaking up our carbon dioxide. But as the planet heats up, those sinks stop working as well. Trees die from drought. Wildfires burn them down. The ocean gets too acidic. So the things we're counting on to save us could turn against us. A dying forest doesn't absorb carbon, it releases it. Instead of a sink, it becomes a source. The paper warns that if we over-rely on these nature-based solutions without accounting for the fact that the overshoot might kill them, we're setting ourselves up for a catastrophic failure. This is a good segue into the 5th factor, overshoot reversal dynamics. I always assumed, and I think most people do, that once we hit the peak temperature and start cutting emissions, things just get better. A nice, steady descent, and then we all have a party. But that's not what the science says. The authors plot various scenarios that show something completely different. They're not smooth, they're jagged. The climate system is chaotic. Just because the 30-year average temperature is dropping, that doesn't mean every year will be cooler. You could have a 5-year period of intense, record-breaking heat right in the middle of the recovery. Like a false dawn. Imagine the impact. The global numbers say we're recovering. Donors say, okay, crisis over, time to cut funding. Aid groups start packing up, and then bam, a massive weather spike hits, catching people completely off guard. The psychological blow of a crisis during the recovery could be just devastating. It breaks the collective spirit. And there's another piece to this recovery puzzle that could cause huge problems. Carbon dioxide removal, or CDR. To bring the temperature down, we have to physically suck carbon out of the atmosphere. That's non-negotiable. We have to go into negative emissions. And most of the ways we know how to do that involve land, planting massive forests, growing bioenergy crops. We're talking about land areas the size of continents. And this is where the authors see a geopolitical nightmare forming. A land crunch. You've got a growing global population that needs land for food, but you also need that same land to plant billions of trees to cool the planet. So who wins? The hungry people or the climate goals? The analysis in the paper points out that this conflict gets more intense during the recovery phase. So just as the weather is supposedly getting better, the political fights over land use could explode. Think of that. The solution itself, sucking carbon from the air, could trigger a famine if you're not careful. It completely upends this idea that recovery is a return to normality. The recovery is its own new kind of crisis. Okay, so we have these 5 factors: duration, geography, timing, adaptation limits, and this jagged recovery. It paints a much messier picture than just it gets hotter. Now, the authors aren't just trying to scare us, it's a very targeted call to action. They break it down for 3 groups: scientists, humanitarians, and governments. Let's start with the scientists. They need to start looking at society. The authors call for a ramping up of research on potential human and social impact, accounting for the various post-peak behaviors. We need rigorous models that simulate how food systems break, how migration patterns shift, and how economies buckle under these long-term overshoot conditions. We need to stress test civilization, not just the atmosphere. We need to find the breaking points before we hit them. Now, the humanitarian groups, they need to learn to manage the deep tension between pragmatism and hope. They can't just cross their fingers and hope the temperature drops smoothly. They have to prepare for the severe volatility of that drop with robust scenario planning for a world where basic human needs are wildly unpredictable from one year to the next. And finally, governments. Well, strengthen the pledges, obviously. Cut emissions now to make the overshoot shorter and lower. But more than that, they need to stop having tipping point tunnel vision. And what that means is governments are obsessed with preventing the peak disaster. Don't cross 1.5. But since we probably will cross it, they aren't planning for the sheer endurance required for the decades that follow. They need to prepare their societies for a long, grinding marathon, not just a sprint. So this whole conversation really reframes the narrative for me. We always hear about climate change as this cliff that we're trying not to fall off of. But this paper says, look, chances are we are going over the edge, but falling isn't the end. It's the beginning of a very long, very difficult climb back up. And that climb has its own set of dangers. That's the key takeaway. The path back to stability might be just as perilous as the path away from it. So for everyone listening, next time you see a headline about net zero or stabilizing temperatures, just remember the overshoot. Remember the gap, because that's where we're all likely going to be living. And remember that averages lie. The experience of living in that gap won't be the same for everyone. It'll be defined by where you live, how fast things change, and if your community can hold together. I just want to leave you with one last thought. Looking at that jagged graph of the recovery, we spend so much energy preparing for the crisis itself. We build the walls, we sign the treaties, but are we at all prepared for the chaos? If the path back to normal involves volatile weather spikes and fighting over land for trees versus food, the recovery might just be the most dangerous part of the whole story. It's the ultimate test for humanity. Can we hold it together on the way back down? It's a massive question, and one we'll be answering for the rest of the century. Thanks for listening to Geoversity Podcast. For more content, check out our website, geoversity.io. And if you want to hear more about this topic of climate overshoot specifically, check out our interview with Professor Deborah Roberts.